Contemporary Physics Top 100 Dilemmas. Episode 5. The Problem of the Emergence of Spacetime Geometry. Do not start with tensors or metrics. Start with a picture everyone already knows. Apples fall along the path that seems easiest. Planets keep to their orbits. Light bends around massive bodies. Clocks run slow near black holes. Horizons, light cones, and geodesics all fit together so neatly that it is tempting to believe spacetime geometry must be the ultimate floor of reality itself, a pre-drawn grid on which everything else simply moves. That temptation is exactly where the trouble begins. The moment you push beyond ordinary conditions into strong gravity, boundaries, black hole interiors, or quantum readout zones, geometric language starts showing its limits. It can tell you that the path is curved, but it does not directly tell you where the slope came from. It can tell you the clock ran slow, but not by itself why that clock was dragged slow. It can draw a horizon or a light cone, yet it does not by itself explain how the boundary actually works, how it filters, how it vents, or how the inside and the outside keep settling their accounts. That is the mainstream headache. If geometry is the final ontology, then many mechanism questions get buried under a beautiful map. You can see contour lines, but not how the mountain was built. You can trace a riverbed, but not how water, sediment, pressure, and banks are doing the real work. But if you say geometry is only an emergent appearance, you hit the opposite wall at once. Why is it so astonishingly successful in the macroscopic world? Why does it behave like such a durable universal map from free fall to gravitational lensing? From satellite clock corrections to black hole shadows? Why does the world keep looking so geometric as soon as you step away from the most extreme regimes? EFT does not solve this by throwing geometry away. It lowers geometry from the throne to the translator's desk. In this picture, gravity is not first a mystical sheet of curved coordinates. It is a tension slope in a continuous energy sea. Structures rearrange themselves along that slope, and at macroscopic scale the motion reads as a geodesic. Slow clocks are not caused by some abstract time fluid becoming sticky. They are readouts of local beat changing because the beat structure sits in a different potential condition. Distance is not a set of bricks prelayed into the universe. It is an appearance of how far relay can proceed, how rulers and clocks get calibrated, and how that calibration is stably booked. A horizon is not a zero-thickness absolute line. It is a high-residence outer critical working skin that breathes, gates, and regulates. A light cone is not causality itself as a metaphysical object. It is the coarse-grained ordering that appears after relay limits, channel openness, and fidelity conditions have been compressed into a simple outward picture. Even spacetime curvature becomes, in EFT, a remarkably efficient translation. Tension slopes get geometrized, beat differences get geometrized, and boundary or channel constraints get geometrized, until what we finally see is a clean, elegant, calculable spacetime map. In other words, spacetime geometry is more like a fusion of weather map, terrain map, and navigation chart than like the raw material substrate. It is brilliant at compressing appearances. It is excellent for quick calculation. It is indispensable for engineering. But it is still a map, not the asphalt, not the bedrock, not the pipes under the road, not the steel hidden in the bridge, and not the real chain of work by which wind, pressure, traffic, and material stress produced the route in the first place. Its extraordinary success on ordinary scales no longer looks mysterious in EFT. Large scales average away an enormous amount of microscopic detail. After that averaging, what remains are the zero-order bones of the situation: slope, beat difference, boundary gating, and relay limitation. Geometry captures those bones with astonishing efficiency, which is why it can look like the emperor of everything. But the moment you enter black hole boundaries, strong gradient zones, or quantum readout regimes, the averaging breaks down, the fine details come back up. The map stops being enough. The actual working chain C condition, beat, boundary, relay, restructuring has to return to center stage. EFT therefore adds an important guardrail. It is not denying the effectiveness of general relativity. It keeps general relativity's unifying external appearance and engineering interface. What it rejects is the claim that geometry has already explained everything. Geometry still has public value as a high-level language, a translator, and an engineering tool. But when the real question becomes where the slope came from, why the clock slowed, how the boundary is doing work, or how extreme interiors keep settling accounts without tearing themselves apart, explanatory priority has to go back to C condition, beat structure, boundaries, and relay chains. Once that is accepted, spacetime geometry does not disappear. It simply returns to its proper place, not as the final oracle, but as an extraordinarily powerful translation map of a deeper material process. Open the playlist for more. Next episode, the problem of the scope of the holographic principle in real physics. Follow and share, and let this series of new physics explainers help you see the universe more clearly.